So one way that we tested for convergence is we would do something called the ratio test. So we look at what happens as n approaches infinity of the nth plus 1 term divided by the nth term. And if that approached a specific value, that was evidence that, that the limit didn't happen to exist in that ratio test. Okay, so let's put that definition to the test and let's run an example of what one does. So we have this interesting pattern of x minus 3 to the nth over 2 to the nth times n. And the question is this going to converge? And then what is the ratio or the radius of convergence for it? So we set it up. So it's the limit as n approaches infinity. And we want the n plus 1 term on top and the n term on bottom. So that's going to look like x minus 3 to the n plus 1 over 2 to the n plus 1 times n plus 1. And then we have the n term on bottom, 2 to the n times n. Okay, and so our task is to try to simplify all these expressions out to see what we end up with. All right, so I'm going to do a little bit of exponent action here because I'm essentially dividing by a fraction, so I can multiply by the reciprocal. But let's think about that x minus 3 to the n plus 1 power. That really means x minus 3 to the nth power times x minus 3 to the first power. And I can do that same analysis with the 2 to the n times 2. And then we have an n plus 1 there. And make sure our limit stays there. And then I'm going to multiply that by the reciprocal of the fraction here. So we got 2 to the n times n over x minus 3 to the n. Okay. Now at that point we should notice some terms cancel out. So we get the 2 to the n's divide out. I have an x minus 3 to the n over x minus 3 to the n. And so the limit as n approaches infinity, let's see, I have n times x minus 3 over 2 times n plus 1. All right, so at this point, we're just going to take advantage of some definitions here. So I can bring the x minus 3 out as the absolute value, which matches the property we looked at for the ratio test. So this expression, let's see, I'm going to bring out the 1/2. And then we have absolute value of x minus 3. And then we're left with the limit as n approaches infinity of n over n plus 1, right? And so that term essentially is going to be 1. As n gets larger and larger, the numerator and denominator aren't really going to make a difference there. So that's going to equal 1, right? So we're left with this 1/2 x minus 3. Okay, so our series converges absolutely. Sorry, going to have that same color texture there. It's going to converge absolutely as long as 1/2 times the absolute value of x minus 3 is less than 1. And we're going to get rid of that. Or we can change that expression to be absolute value of x minus 3 is less than 2. Just multiply by 2 there. And if we think back to the definition of absolute value, that says that negative 2 is less than x minus 3 is less than 2. So if I add 3 to both sides, That's going to give me a 1 there. Is less than x is less than 5. So the radius of convergence is 1 to 5. Question is, as we talked about a second ago at that number line, what's happening at 1 and 5? So is it convergent at those specific values or not? So let's see. When x is, or n, oops, dropped my inequality there. Okay, so let's test at 1 and at 5. So at 1, we got 1 minus 3 to the n over 2 to the n times n. Okay, so this is going to give me essentially an alternating term, because I have negative 2 to the n over 2 to the n times n, and I bring that out as negative 1 to the n times 2 to the n over 2 to the n times n, right? That's going to give me negative 1 to the n over n. Okay, so now we got to go back to our earlier definitions from, I think, Cal 2, is if I have a series that, let's see, let's look more like alternating series. So alternating series would be the limit as n approaches infinity of a given term is 0. And in our case, if we go back to our original function here, if I have x minus 3 to the n over 2n to the times n, that denominator is huge. So that's a check. Yeah, definitely infinite term would approach 0 on that. And then what about the sequence? So is the sequence decreasing? So I got negative 1 to the n over n. Is it true that negative 1 to the n over n plus 1, that it's, that my first term is going to be bigger than my second term? And that alternating part is not really what we're focused in on. It's more that denominator. So the fact that your denominator is larger, and as you go to the next term, it's going to get to be a smaller denominator, which means your fraction is getting smaller. So your sequence is in fact decreasing. So sequence is decreasing, which by the alternating series test means our series is convergent. Okay, so what does that mean so far? That means on our interval, we can now put a bracket on the 1, because now we can say that I know it converges at that endpoint. So what about at the 5? Okay, so let's build this up. So 5 minus 3 to the n over 2 to the n times n is 2 to the n over 2 to the n times n, and that is 1 over n. And that actually is a textbook definition of a divergent harmonic series. So it is actually divergent at 5. So coming back over here, that means our radius of convergent would be a bracket on 1 and a parentheses on 5.